Good morning, students. We are in the exercise of 2.2 of class 10 polynomial. Here we have to learn certain things. The first is relationship between the zeros and coefficients of a polynomial. That is the most important thing. Relationship between the zeros and coefficients of a polynomial. And the second one is formula for framing a quadratic polynomial when its zeros are given as alpha and beta. Alpha and beta. Now, we will start our journey from this point only. First, we will understand what is the standard form of a quadratic polynomial. The standard form of a quadratic polynomial is Px. You can write fx, gx, rx, whatever you like. I am denoting it by Px. Px means polynomial in x. Fx also means polynomial in x. Px is equal to ax square plus bx plus c, where a, b and c are real numbers and a not equal to 0 is called a quadratic polynomial. If anyone asks you what is a quadratic polynomial, your answer will be a polynomial in the form of ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0 is called a polynomial of degree 2 or a quadratic polynomial. And we know that there is a relation between the degree and zeros. Since the degree of a quadratic polynomial is 2, so it will have 2 zeros maximum. Its 2 zeros are alpha and beta. We have supposed that its zeros are alpha and beta. Then the relation between zeros and coefficients, most important thing. See, in this polynomial, a is a coefficient, b is a coefficient, c is also a coefficient. A is a coefficient of x square, b is a coefficient of x, and c is a coefficient of the constant term. And its zeros are alpha and beta. And what is the relation between these zeros and coefficients? Sum of the zeros, that is alpha plus beta, it always will be minus b by a. It means, what is minus b? Minus coefficient of x divided by coefficient of x square. And the second relation, in case of quadratic polynomial, product of the zeros, that is alpha beta, alpha into beta, equals to c by a. C means constant term upon coefficient of x square. So students, we are finding that in case of a quadratic polynomial, the standard form is ax square plus bx plus c, abc real number, a not equal to 0, and there are two relations between the zeros and coefficient. The first one is sum of the zeros is equal to minus coefficient of x divided by coefficient of x square, and product of the zeros is equal to constant term upon coefficient of x square. We will see how this relation is derived. Now come to the standard form of a cubic polynomial. A cubic polynomial, a polynomial which is in the form of px equals to ax cubed plus bx square plus cx plus d, where a, b, c and d are real numbers and a not equal to 0 is called a cubic polynomial. And since a cubic polynomial has the order of 3, it must have maximum number of zeros. It will have 3, and that is, let it be alpha, beta and gamma. Gamma is the third zero. Alpha, beta and gamma are the 3 zeros of the cubic polynomial. Now see the relation between zeros and coefficients in case of a cubic polynomial. Remember, it will have 3 relations. Quadratic polynomial, there are only 2 relations. In case of cubic polynomial, you will have 3 relations. The first relation, alpha plus beta plus gamma, that is the sum of the zeros, is equal to minus b by a, is equal to minus coefficient of x square divided by coefficient of x cube minus coefficient of x square divided by minus coefficient of x cube. The second one is alpha beta plus beta gamma plus alpha gamma equals to c by a. What it is? Sum of the product of the zeros taken two at a time. Alpha beta, three zeros are alpha beta gamma. Alpha beta, beta gamma, alpha gamma. These are the product of the zeros taken two at a time, and its sum. Sum of the product of the zeros taken two at a time is alpha beta plus beta gamma plus alpha gamma. It will be c by a. It will be coefficient of x divided by coefficient of x cube. And the third relation is alpha into beta into gamma is equal to minus d by a. What is alpha into beta into gamma? That is the product of the zeros. The product of the zeros will be equals to minus constant term divided by coefficient of x cube. Hope you are finding what I have written on the board. Now, one last thing you have to remember, you are given with the zero of a quadratic polynomial. We know there are two zeros of a polynomial, quadratic polynomial, and let them be as alpha and beta. If alpha and beta, these two zeros are given to you and you are asked to frame a quadratic polynomial, your formula will be px equals to x square minus alpha plus beta into x plus alpha beta. In other words, you will write x square first, you will give a minus sign, you will add up the zeros, sum of the zeros into x plus product of the zeros. So this formula you have to remember. Now, before going into details, we will see how this relation of the quadratic polynomial is framed. How we will frame this quadratic polynomial. So, students, pay attention. This is very important derivation. Standard form of a quadratic polynomial, px equals to ax square plus bx plus c. When a, b, c are real number, you have to write an a not equal to 0. Its two zeros are alpha into beta. Now, since alpha and beta are two zeros of px, therefore, x minus alpha and x minus beta are two linear factors of px. Is px equals to k into x minus alpha into x minus beta, or px means ax square plus bx plus c equals to k, it will be x square minus alpha plus beta into x plus alpha beta. I have multiplied these two terms and I have written in this way. Now, ax square plus bx plus c equals to kx square minus k alpha plus beta into x plus k alpha beta. Now, on equating the coefficients of like terms from each side of the obtained equation, we get a equals to k, because here ax square and this is kx square, its coefficient is a, it will be equivalent to, it will be equal to k. First one. Now x's coefficient is b and x's coefficient in this case is in this side, in right hand side, it will be minus k alpha plus beta, or this one is a equals to k, then b equals to minus k alpha plus beta, or b by minus k equals to alpha plus beta, or alpha plus beta is equal to minus b by a. Why? This is from 1. From 1. We have put the value of k equals to a. So alpha plus beta equals to minus b by a. And third one, similarly, the third term c equals to k into alpha beta, or c by k equals to alpha beta, or alpha beta equals to c by a from 1. Therefore, our relation alpha plus beta, sum of the zeros is equal to minus b by a minus coefficient of x by coefficient of x square, and alpha beta is equal to c by a, product of the zero equals to constant term by coefficient of x square. This is how we will derive the relation between the zeros and the coefficients. Now students, let us directly come to exercise 2.2. I hope you have understood this derivation. You will practice by yourself by writing it by your own, and you will learn it, you will get it by heart. And now we will see the exercise questions given in your exercise. 2 questions are there. The first one is, there are 6 questions. In question number 1, I will explain only one for you. Suppose question number 6, I have taken the polynomial, let, they have not given any name, we are naming it, let px equals to 3x square minus x minus 4. Find the zeros of the quadratic polynomial and verify the relationship between zeros and coefficients. For finding the zeros, of px, we equate px with 0 and solve the equation for x. That is, px equals to 0, 3x square minus x minus 4 equals to 0, or 3x square minus 4x plus 3x minus 4 equals to 0, or we will take x as common, 3x minus 4 plus 1 as common, 3x minus 4 equals to 0, or 3x minus 4 into x plus 1 equals to 0. Product of two numbers are 0. Therefore, either 3x minus 4 equals to 0. That gives us 3x equals to 4. That gives us x equals to 4 by 3. Or x plus 1, that is the second factor, is equal to 0. That will give us x equals to minus 1. Therefore, the two zeros are alpha equals to 4 by 3 and beta is equal to minus 1. So two zeros we have got. How? It is a quadratic polynomial. We equated that polynomial with 0. It converts into a quadratic equation. We have done the midterm factorization. We have calculated the value of x as 4 by 3 and 1. So whatever value of x we are getting, those are the zeros of the given polynomial. Now the second part of the question is relation verification. Relation verification. First relation, alpha plus beta. What is our alpha? 4 by 3. What is our beta? Minus 1. So 4 minus 3 by 3, that will be 1 by 3. Now you find out b by a. B is the coefficient of x. What is the coefficient of minus b by a? What is the coefficient of x over here? Minus 1. So minus of minus 1 divided by coefficient of x square, that is 3, that is 1 by 3. Therefore, alpha plus beta is equal to minus b by a, verified. The first relation is verified. The second relation, product of the zeros, alpha into beta, 4 by 3 into minus 1, that is minus 4 by 3. Now c by a calculate, c by a. Our c is what? Minus 4. What is our a? 3. So c by a is equal to minus 4 by 3. Alpha beta is also minus 4 by 3. Therefore alpha beta equals to c by a, and that is the second relation, that is also verified. In this way, we have to show the verification. We will calculate the two zeros and we will go for the verification, the relation verification. Now question number 2 we will discuss right now, and that is there are six questions. One question I will discuss for you. Again, that is question number 6. You will do the rest of the questions in the same way. Students, I hope you are following me, you are getting what I mean to say. In case of any doubt, feel free to ask me the questions. Question number 2, 6 of question number 2, you are given with two zeros are. Two zeros are 4 and 1. And what you have to do? You have to find a quadratic polynomial. Now simply let alpha equals to 4 and beta is equal to 1. Therefore, alpha plus beta will be 4 plus 1, that is 5. And alpha beta will be 4 into 1, that is 4. Now the required quadratic polynomial Px is equal to x square minus alpha plus beta into x plus alpha beta. Now x square minus, what is the value of alpha plus beta? That is 5. 5x. What is the value of alpha beta? 4. So the required polynomial is Px equals to x square minus 4x plus 4. Yes, in this way we will frame the quadratic polynomial. Hope students you have understood what I mean to say, how to frame a quadratic polynomial whose zeros are given, how to find out the relation between the coefficients and the zeros of a quadratic polynomial. In the same way, we can derive the relation between the zeros and coefficients of the cubic polynomial also. So you will go through now exercise 2.2 and revise the verification once again by yourself, which I taught on the board. And in the next class, we will see the division algorithm of the polynomials. Till then, students, goodbye.